traditionally, right, we pick a point, and from that point, if you have a slope, a line that with a certain slope, we know what the tilt looks like. So you, okay, yes, those are the points that's on the line. Now, if that point is x0 and y0, you can think of it as, well, if you start from the origin, let's first get to that position. If a vector starts from 0, 0, what is the actual coordinates of this vector? Let's call it a P0 for position vector. It will be x0, y0, because you're starting from the origin. Okay, from there, what we do is, well, it seems like the direction, okay, so not the magnitude, the direction of this line is AB. So let's call that, let's say, D. And you see, from the position, if you add AB, you'll get to a single point on this line. But if you vary the different constant, you'll get to a different length. You'll get shot up to a different length in that particular line. Right? So this is called the vector form of a line. So it's in this form. We usually say the resultant vector is the position vector plus t, the direction vector. This is vector form. Okay, every term here has two coordinates. It's xy, x0, y0, plus t, ab. So I can actually separate the x and y. X will be x0 plus at, y will be y0 plus at. If you separate it like this, so you can just find out x and y separately, this is called a parametric form. Of a line. Okay. So, why do we do this? We already have a form. We already have y equals mx plus b. Why do we need this? Well, if you extend it to 3 dimension, in 3 dimension, what's the slope of 3 dimension? It no longer makes any sense. What's the rise and what's the run in 3 dimension? Okay, maybe you can say rise is z, but what's the run? It can be x or y, right? So it's confusing. But if you wouldn't be confused if you say, okay, here's a point in 3 dimension. Here's a point, and go in that direction only, or multiple of this direction and multiple. So you'd only end up in this particular 3D line. I made a mistake here. This is BT.